Hi, welcome to the break disk tutorial. We will start this tutorial by first modeling the disk and then the calipers. For that purpose we first need to collect the data of the target model. This is our target model. We will collect its data and remake it separately. So we start by measure tool. We click on these two faces. This gives us the thickness of the disk. We will note it on a sticky note here, 4.5 millimeters. Now the distance between the two disks is 7 millimeters. This is same as the other one. Now let's measure the diameter, 170.54 millimeters. Now let's start by modeling the disk. I make the circle of 174 millimeters. I just forgot it precisely. It is 170.54. Here I put it again. Okay, now I make the extrusion 4.5 millimeters. Now see that two sides are exactly similar to each other, so I will first complete the model of one side and mirror it on the other side. Let's see the orientation of these holes with respect to the disk. Let this be the internal diameter, 99.44 millimeters. I remove the material from here. Okay, now let's see the orientation of these holes with respect to this circle. The starting circle of both these series of circles lie on the same circle from the center of disk. Let's measure the diameter of this circle, 348.17. Let's note it down here. What's the diameter of these holes? It's 2.56 millimeters. Number of these holes are 1, 2, 3, 4, 5, 6, 7, 8, 9, and distancing of these holes is 5 millimeters. Okay, now we have enough information about the holes. Now let's see what angle does this line make. Let's draw a straight vertical line and measure the angle of this construction line with this construction line. This is 84.29 degrees. Let's note it down too. Now we have enough information to make these circles. For the second line, let's measure the angle again. It is 84.71. Let's measure the distance of these two circles. It is approximately 10 millimeters. What is the distance here? It's 5 millimeters too. What is the number of these circles? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have enough information to model these circles. Let's start. Again, open up the part I was making. I draw a construction line like so. A construction circle of 348.17 millimeters dia. Oh, this circle is quite huge. I guess I did some mistake in measuring this circle. Let's measure it again. Oh, it was the length that I recorded. The diameter is actually 110.83 millimeters. I can change it here. Okay, this is now fine. Let's make it a construction circle. I make 2 circles here. These must be equal in diameter. Let's see what is the diameter of these circles. 2.56 as I measured earlier. The distance between the circles was approximately 10 millimeters. Let's also measure the distance of this circle with respect to this line. This along z-axis it is 22.32. Let's make the 2 lines along which we have to pattern these circles. Now we need to define the orientation of these lines with respect to the straight line. What we measured here is 84.29 degrees. And the other one 84.71 degrees. This might be 84.7 degrees from the other side. This means that it should be 180 minus 84.71 degrees. Now it looks fine. Now I pattern these circles as along this line. A sketch only supports the pattern along x or y axis, so I will pattern as a feature. Now I remove material. Okay, let's pattern these circles along the line. I have to do it manually. One, two, three, 4, 5, 6, 7, 8, 9. Millimeters as measured. Now all circles have equal diameters. I will apply the equal constraint. Like so. Now I will select these circles and copy them over here. Now I need to rotate them along the new line. This is not working, I guess. So I will make circles here manually as well. Okay, 9 circles are complete. They all are equal. Again applying the equal constraint, like so. Okay, now circles are done. Let's see how many of such circles are on the disk. These are 1 2 3 4 5 6 7. I'll pattern them along the circle. It is a circular pattern along this circle and numbers are going to be 7. These all are equally spaced. This is done. Now let's see where this lies. The depth of this cut is 0.6 millimeters. The distance is 0.94. Its angle with the line is 66.68. And let me save these measurements. 0.6 mm depth, 0.94 mm thickness, and approximately 66° angle. And total length is 40 millimeter. Let's take it 40. And its distance with this line is 2.84 millimeters. Let's make it now. This is 66 degree, 2.84 millimeters. Length is 40 millimeters. And thickness is 0.94. I use the offset command to create this thickness. Let's join these lines. Now depth of this extrusion is 0. Oh sorry, this is not an extrude, this is extruded cut. 0.6 millimeters. This is curved from here. I use the fillet command on these two edges. They are going to be equal to 0.6 millimeters, equal to the depth, like so. And let's pattern this. From the feature manager design tree, let's put the circular pattern down here, and let's include these two features in the pattern. We again added the pattern. In the features, I add this cut and the fillet, like so. So these lines are patterned all along the disc. Let's see what to do next. Okay, I see that disk is complete and we just need to mirror it on the other side. Since the distance between the two disks is 7 millimeters, so we create a plane at a distance of 3.5 millimeters, that is 7 millimeters divided by 2. Let's mirror this feature around this plane. We select the mirror command, select this plane as a mirroring face and mirror this whole body like so. Okay, these two bodies, since these are completely separate at the moment, so it is displaying the errors that it cannot be merged. So I will uncheck the merge solid option and this can now be mirrored. Now what remains? These internal blades or whatever these should be called. I need to count their numbers starting from here. One. Let's section this view. Alright. These are patterned around a circle and their number is, instead of counting all, I just create a sketch here, create two perpendicular lines. And let's see how much lies in the quarter of this disk. One, two, three, 4, 5, 6, 7, 8, 9. 9 into 4 is 36. So I will make 36 such blades. To get the profile of these blades, I just use the convert feature command and get the profile. Let's measure the diameter of inner circle. It is 99.44 millimeters. Let's copy this feature. I will move these entities from here to here. I will delete this circle, I will delete this line, I will delete this line too. The extrusion of this part is equal to the distance between the two discs, so it will be extruded around 7 millimeters. I forgot to join these lines. I again make the circle over here. I will trim this circle around this. Now I can extrude it 7 millimeters, like so. And these will be patterned around the whole circle, just to visualize how it is going to happen. I will temporarily make it transparent. Like so. Now I will select this feature, do a circular pattern of around the circle. We calculated it to be 36, but to lie exactly between these circles, it should be a multiple of 7, that is 35. So our approximation was correct. It is just a matter of 1 digit difference. Now let me show you what happens if I put it 36 here. These will intersect these circles. This should not happen. So this is 35. Now I will remove this transparency. Okay. The disc is almost completed. Only one part is remaining. One feature, I'm sorry. Oh, so the the cut of the disc on the other side is greater. We will measure this circle. It is 106.69. We will make the changes accordingly. This is 106.69 by 2 radius. This is correct. 4.5 millimeters. Okay, they still got some distance from the circle, so I have to move this feature slightly outwards. I will go into its sketch, move it slightly down, like so. So that it is not intersecting here anymore. Now I will save this part, desktop, break disk, this is done. One feature remains. Its diameter is okay. I see that there is some draft on this feature. That's otherwise it just gives the diameter when we measure it. Now it is giving the perimeter and area. If we see this from the side view, it has a draft angle. We need to measure the draft. We will go into the top line, sketch, we measure the angle from this line to this line. I'm still not able to get the angle. I will trace over this line and this line, get their projection, and now their angle is 92 degrees. It means there is a 2-degree draft. Let's measure the base of this. It is 92.72 diameter. And its height from the base is 15 millimeters. This feature can be more conveniently drawn by the revolve feature. Let's check out what is the thickness. The thickness is 2 millimeters, 15 millimeters height, and 88.79 internal layer. Let's make it by revolve feature. We select the top plane, I'm going to sketch, and we draw a center line around which we need to revolve. Now we draw its profile. It is, the inner circle was 88.79. This was 88.79. This line is here. Its angle with this is 2 degrees, since it was a draft of 2 degrees. It is 4.5 millimeters below this face, like so. We join it here, here, here. Now since the thickness is 2 millimeters, we will offset the thickness by 2 millimeters. This line is parallel to this line, and the height from this surface of this line is noted to be 15 millimeters. This goes here. The distance between them is 2 millimeters. Let's make it 2. We trim it off from here, and now this joins here, this joins here, and distance between these two faces is also 2. Now let's use the revolve feature. Just to show it as a separate feature, there's a slight dip. It is like this in the given model. We trim it here. Now let's see, that's how the original model appears. Let's measure the radius of this fillet. It's approximately 1 millimeter. We make it 1. Let's do the remaining part. These are 5 circles. The center one is 23.66 and they are 6.71 and their distance is 24. Let's use the round off values. This is 26. The distance is 24. 24 into 2. Let's make it a construction circle. And we make in this circle here, this is 6.7. Let's pattern it around like so, and we cut it through this. Okay, our disc is done. Now let's make the calipers. Let's copy the profile of this part. continue like this. Okay, this much is enough for the first feature for the caliper. This was the center. We will mirror it since it was symmetric. Let's mirror it. Now see what is the total depth of this. It is 26 millimeters. Okay. There's a small sketch missing. I make an arc here. this is connected now. I think I can now extrude it. Okay, I have to do that from this side as well. Use the fillet command. This is done. Let's attempt to extrude it again. Okay, there might be some gaps still left. Let's analyze it. Okay, here I got it. Now I hope I can extrude it finally. Oh yes, this is 26 millimeters. The gap is let me check. It is around 19 millimeters. Let's round it out to 19 millimeters, and this gap is now we have to make a cut inside it of 19 millimeters, keeping the thickness of this part to be approximately 4 millimeters. From the top view, I have to cut it by 45 millimeters. Okay, let's do it. Let's try to use the shell command. Let's use the thickness to be 4 millimeters. Okay, this is fine. Why this remains? I think I forgot selecting it. Yeah, here it is. On the other side it is here. Let's shell it. Okay, now this looks fine. It is a 18 also. So we further select to make it 19. .5. Let's make it 4.5. Now this should be around 19. The distance is sorry, it should be 3.5. Okay, now it makes 19 millimeters. Now from top I have to remove 45 millimeters on one side. From here, this is my center line. Let's say the center rectangle is around 5 millimeters. From this I will make a rectangle of 45 millimeter length. The thickness should be 19 millimeters, and these lines should be symmetric about this line. Now I mirror this about this line. Now I trim the unnecessary portion. And now these will be used to cut the material, like so, and this. Now in the similar manner, we will use the same method. We will go in the plane, we go into the sketch, we either trace over these boundaries and copy the sketches to our new part, or we can also use the convert entities command to completely create this in the other file. For the current case, I will use this complete body let me extract this part out of this. I will remove material from here as well as here. Now, for the sake of convenience, since I have explained the method of all features, I will directly use this part to assemble with the brake disc. Just to remove this logo. Like so. Logo's gone. Let's write anything else here on the line. Disc brake. I will extrude it to 0.1 millimeter length. Now let's save it over here. Let's assemble it now. Here comes the disc. Here comes the calipers. Now to align them, let's make a new plane on this part. To draw any plane between the middle of two faces, you just click those two faces and the plane is created between them. So just to align them, I have created these two faces. Now turn on the face plane. I made these planes now like so, and I will make the right plane of disk with this plane. Here it goes. Finally, we have completed our disk break. Just to give it a better look, I will turn on the real graphics and ambient occlusion. Okay, this is the final model of the disk break. Thank you for watching.